So, my name is Tatiana Boye and I work for an ILS department located in Germany. And since around 1.5 years, we've got the luxury of having a dedicated R&D team in our company. And it's worth actually a separate discussion of how to establish an R&D group and what could bring to your company. But today, I'm going to talk about another challenge we have, namely software monetization challenge. And the idea of this presentation is actually to share our experience and maybe to give you some hints on what questions should you ask yourself if you try to go this way yourself. So first, a small agenda. So first we'll talk about what is software monetization in general, because for many of you guys it can be a new term. So we'll start with our first 7 steps in this challenge, and then through investigations, depression, and then eureka, we will reach an ambiguous ending. And actually, this weird picture you see, I would say that it's the best one I could find to illustrate the journey we had. And maybe in the end you will agree with me, or maybe not. So let's start with the thought that software monetization is amazing. So actually, it's quite a new term. I think, according to Wiki, it appeared in 2010 or something. And actually, it's more than just licensing. So it covers IP protection, it covers also licensing, pricing, packaging, entitlement management, also user tracking. And the main idea of that is actually to maximize the profitability of your software. So of course, you want to prevent unauthorized copying and usage of your software if you want to get money. But the idea is also to capture a new revenue stream. So with smart packaging of software, you can sell more. You can get money for more. And I would say it's a must to have it when you work on products, as we do. But also it's something that you should consider even if you don't work on products but on projects, because somehow it helps you thinking in terms of reusable code that you could sell to your customers. So first question when you start thinking about that is, of course, whether you want to buy a solution or you want to build the solution by yourself. So it's a very classical question. Why would you buy it, actually? Let's start with building. Why would you build it, actually? So, first of all, you're a smart engineer, so you can build it, of course. There are some good things about that. So it will be a tailored solution, because it will be unique. And more likely, no one will know how to hack it just because it's so unique. You won't get any subscription costs, you won't be dependent on any other company, so it's actually good. But why would you buy it? It's not our core competency, so you don't have unlimited resources, and actually maintenance can be a real help in this case. And any commercial solution would be better than your solution, because you just don't have unlimited resources. So before we started with this monetization story, actually we had, of course, we had protection for our products, but it was just a dongle. So you plug it in, it works. You plug it out, it doesn't work. That's it. But we were not that happy because it was just one dongle for all our products, and yeah, on a weekly basis we started to get bug reports like. Sometimes license check just fails without any reason. So it was not a reliable solution anymore. So in our case, we decided to go for an off-the-shelf commercial solution, but basically you should decide by yourself. There is a very good article on Software Wiki blog, whether you should buy it or build it, and you can decide for yourself. All right, so we are buying something. So we are customers in this case, and we wanted to be good customers, and we didn't want to underestimate the value of requirements. So we started with requirements, and we tried to collect ideas of many different people, because different people, they have different focus, and it really helped us to cover different aspects of that. And when you create requirements, so think about use cases, think about the whole workflow, how your users will purchase your software, how will they activate or deactivate, so where will be your licenses or located, will be in the cloud or inside your intranet, so things like that. We had a list of around 20 requirements, and we started to analyze the market. And actually, first thing we realized that there are lots of them, these commercial solution providers with really similar features, and it's really hard to decide what to choose actually. So besides the requirements, we actually wanted to get a feeling that the solution we will go for will be somehow reliable, so it won't be affected by a Windows update that happens every day now. And and also it was very important for us also just to get a feeling that we will get support, because it was a very new topic for us. Of course, we had this story with Dummies, but it was just a few lines of code, it's not more. But to implement a real big commercial solution was very new for us. So we wanted good support. When we were analyzing the market, of course, there is one solution that has a real benefit. It's a software key solution that is used for all products, I think, on the network network. So it has one great benefit. It's integrated into LabVIEW, so it brings a lot of safety, of course. But from our experience, unfortunately, it also has numerous drawbacks. So we didn't go this way. And actually, we went for a Monetization solution. So it's it's not that this company implemented something. They acquired, I think, Sentinel or SafeNet, and they acquired something else. So actually, this story is like 30 years old, and if you remember these Aladdin keys, so it's all the same. Again, so we are not promoting anything, so you can decide by yourself, but this was our choice. Yeah, sure.
Did you consider the BLT, the one by Matthias?
No.
Okay.
Just didn't know about it.
You didn't know about it?
All right. So we've chosen the provider. We signed the contract, got our starter kit, and we, after dealing with our IT guys, we got something like this. So we had our entitlement server where we can actually generate licenses, so it's all in our intranet. We have our build server that has a key that allows us to build something that uses licensing. We've got our network license provider with 10 network keys for developers that are inside our network. And we've got a package of hardware keys for developers that are built on site. And basically here you see this firewall. We couldn't break it actually, so our customers at the moment can't directly access our data server to activate, but in fact it's possible. So this wall is just our IT guys wall, but in fact it's possible. All right. So once you have your structure and you have everything installed, the next thing is actually to define your portfolio. So everything needs to be structured. Your portfolio, product portfolio also needs to be structured. So we started with creating feature list. So in a Sentinel solution, so the topic piece is a feature. So feature can be a specific functionality of your application or module. It can be the module itself, and it can be also the entire application. So once you have this list of features, you can define your products. So every product will consist of a list of features. Then you need to define how you will sell it. So what will be your license model? Will it be a perpetual model or time-based or subscription or whatever? And actually what we realized that it really helped us to locate some problems with modularity, because when you can't reflect your products in your licensing model, it means that you have some problems in your software structure. So we did some changes to our software at this stage. And yeah, actually for this step, we would need to have a product manager, but we don't have it. So this is something that we also did by ourselves. All right. So what actually we were going to protect? So what products we have? So we have a huge software package that consists of .NET executables, .NET DLLs, LabVIEW executables, plugins in form of PPLs, and also API, and also decimal sequences. And that all, yeah, we wanted to protect. So the next question was, whom are we going to protect that from? So you should always remember that once you release your software, it starts to be executed in a so-called untrusted environment, also known as a customer machine. And actually, there is no software that is uncrackable. And actually, all protection, it just helps good people stay good. Because it's like your lock. So if someone wants to enter, he'll just break out your door. But it doesn't mean that you should keep your door open, right? So, actually we should always have some reasonable measures of security. And these measures actually depend on different things. Of course, they depend on the values of your software, so you should think about whether it's really valuable or not. Hopefully, yes. On the geographical region of distribution, because we know that in some countries it's really normal stuff just to crack software. Maybe you have history of previous cracking attacks and also target market. So what does target market mean? Whether you sell your software to an individual or to a big company. So individual maybe can crack it or at least try it, and big company won't do that, more likely. So could it be just a software developer that will crack your software or try? Yes. Because we are all curious, and most of the people I know, they try to open password protected VS just to see what's there. So could it be let's say, amateur hacker? Yeah, maybe. Depends on, again, the value of software and all the answers. Could it be a real hacker? Don't flatter yourself, so more likely no. So we focused on, let's say, 1.5 of these guys. We decided, okay, it should be somehow, secure in terms of an average developer, and somehow, we will try to do our best. So, finally it's time to answer how we want to protect. And from a philosophical point of view, I really like 2 quotes that I found. So first one is from a Dutch cryptographer, I think this quote is from 19th century or something, not sure. So it was, formulated for military systems. And it says that a system should be secure even if everything about the system except the key is public knowledge. So it means that you can give your system to your enemy, to your customer. And, and actually nothing will happen, so you will sleep well. And then the second quote we used was a philosophical background. Distrust and caution are the parents of security. So I think you know this guy. So we started with, with the simplest thing. We started with protecting our DLLs and executables. So our solution from Tomato offers a special tool. Also, I think it's in software kits, it's available. So Tomato calls its envelope, software key, and how. So it allows you to have your executable or any other binary, so you don't need source code, and you just say, okay, I want to link my application to this feature number. And that's it. And everything is done by this tool. And the good thing about that is it's not your responsibility, so you just configure that, and then it works. So it also provides some checkboxes for debugger detection, whether you want to have periodic checks, so like check my license once per 5 minutes or something. And it also provides you ability to say that your application will be able to read some encrypted files. So magically it worked with LabVIEW executables, because we were not sure actually, because you never know whether it will work or not. But magically it worked. And we tried it, we did some tests afterwards, and actually some simple tests like unplug the key and see what happens. Yeah, of course. And interestingly, our .NET executables took 2 more weeks to protect, because we ran into some weird issues, and LabVIEW was better this way. But I need to mention that if you attended the session yesterday about hacking LabVIEW executable, this tool won't protect you from that. So still, your server will be available, and you will be able to get the list of your VS and do whatever you want, unless your key is unplugged. So when it's unplugged, this tool will stop all threads, and the server will die. But otherwise, you can do whatever you want. But the thing is that you don't have any code that protects your software in LabVIEW. So it's a different thing. So it's kind of safe, unless you have some really sensitive data for some reason inside your functionality, let's say. All right. So we were quite happy because it just works with a few clicks. And then we realized that we need to protect something more. So we had PPLs and API left. And for them, the only solution, there's no solution out of the box, so there's only API. And it brings, maximum flexibility and maximum vulnerability, because you will find it in any user manual for any licensing API. Something like this: transfer protection is proportional to the degree to which the API functionality is invested in implementation. It means that you're responsible for everything. So if you do some stupid stuff with this API, it's your problem. So we found out that there is a toolkit for Jamal's solution on LabVIEW, toolkit network, and we were really happy. So it's good to have a toolkit. So it was a very good start again. And we downloaded the toolkit, and we decided to look what's inside. So here you see a logging function, log diagram of logging function. So for me it was quite frustrating, because I don't like such virus, so some controls were inside the case, and also some strange comments. So I didn't like it, and then I just ran it, and I realized that I've got a pop-up window with an error message, and I realized that there is a dialog window inside. So a dialog window inside the API. So it was kind of frustrating, and we decided, probably it wasn't written by LabVIEW guys, so we can't use it as it is. So we don't want to use it because it just throws up some pop-up windows. And actually it's quite sad when you have a tool but you can't use it as it is, so you need to create a branch or whatever. So, all right. But the good thing is that we realized that the API doesn't depend on license type, so you can work with any kind of license, like software key or hardware key. So that is not about that. All right. So we decided, we create our own API. So if we can't use it as it is, so we create our own one. But at the same time, so looking at this, also some questions started arising, like, so this is a login function, but there is a vendor code, vendor key. It's a very, very long key that you should, keep safe somewhere. And it was in the control. Also, this path to TLL that actually does the thing, it was like a control again. And we started to ask questions. So you might think that I'm complaining about this toolkit, but actually I'm not, because it was a good thing just to provoke some questions, whether it's a good way to implement it. So we had some questions like, is it safe to just use indicators and controls for such data? Do we really need to have this DLL pass as input anywhere? What if someone replaces DLL and things like that? And actually, at this point, we started actually thinking about how should we do that. And the next thing we did, so we just started with a simple test. So since we want to protect the PPL, let's create just a very stupid PPL. So it's LabVIEW with a public VI and a super private VI. And public VI just calls super private VI. That's it. All right. So we created a packed library. Of course, there was only public VI in the export list, it's clear. But also we couldn't get any dependencies on public VI. So we were able to open the reference, but there were no dependencies, just empty. So no errors, no dependencies. Okay. So we thought, okay, super private VI is invisible, that's great. So we can, somehow think that it's safe. But then we started desktop execution tracing. And so as you can see, super private VI is here. Of course, no one told us that, that super private VI will be protected, but still we were somehow disappointed. All right, so name is something we decided. If we know the name of super private VI, and if it's in memory, so for instance, we open our public VI and automatically our super private VI is in memory. So if it's not re-entered, then we just open the reference, that is all we need. If it's a clone VI, then we need to know this magic number. But desktop toolkit will provide you with this number, no worries. It may cause LabVIEW to crash, as help says, but anything can cause LabVIEw to crash, so it doesn't matter. All right, so we could get a reference of our super private VI. We have a reference. What will we do? So there are a lot of class methods that you can apply to a reference. There are a lot of appealing methods like save instrument and run VI. They would work, fortunately. So more likely it will say like the VI is out of scope or something like that. But there is still one very important thing. Again, as with executables, you are able to get all controls and indicators values using the reference of super private VIs. So again, it's nothing new here, but it's super private VI that is hidden somewhere in our pack library, and we didn't want anyone to have access to our controls and indicators. That was really frustrating. And actually, we found another way to get all this data, because no one really likes polling here, I think. So there is a feature that actually, as a CLA, I didn't know about. It's called data logging. How many of you know about data logging? Okay. It's good that, not everyone. So you just need to have a reference again, and then you just say, okay, I want to log everything at finish of the VI. And you just, put the path of your log file. Then you run the caller, the public VI that calls your super private VI, and that's it. There is a data log file that has all information about your controls and indicators in the data log file. The only small problem is that you need to know the format of data. But actually it's not a big deal because it's always be timestamp in the beginning, and then it will be front panel date. It of course depends on your BI. But you can get this information just using, again, control value, get all, or you can check the header of the data log. So it's possible. You can read all data, and you don't need to call anything, so you will just have a file. It's amazing. Yeah. So we tried that with different VIs, with public VIs, private library VIs, private class VIs, independent VIs that were just acquired by PPL, VIs with block diagrams, without block diagrams, so it all worked. We had VIs with front panels, and then we thought, okay, maybe it's something about front panel, and we found this note in help file that actually this control get all method should work only if front panel is enabled. Okay, we thought we didn't disable the front panel, so we didn't check this remove front panel. So we opened our build specification and explicitly said, okay, we don't want our super proud VI to have front panel. But it didn't work. So we were still able to get all data of our super proud VI. And also we tried to switch off debugging explicitly, not for the whole library, but for the VI itself. So we tried all checkboxes. We didn't find the magic checkbox. If it exists, I would be happy really.
What's in the VI? Because stuff in the VI will make the front panel stay open. Or is there nothing in the VI in the super private VI?
It depends. So if you want to have, so the super private VI is just an example of any API VI we wanted to use. So it will have something. It will have some inputs and outputs. Right?
Yes, but normally front panels will be removed, and it won't be removed if there are property nodes or event structures in there.
Yeah, but there was nothing. Just
it has no
nothing.
front panel, but the inputs and the outputs are there.
It's a connector pane, it stays there.
Yeah.
It's like this control value gets all, you just register it once and then
Yeah.
it gets all.
Yeah.
Yeah, so
Even
it's,
without the front panel loaded. So
Yeah.
it's not the front panel controls that you're reading, it's the connector pane.
Yeah.
So the idea here is just we can't avoid it. If we have a sub-VI that has some inputs and outputs, so more likely the front panel will be always there. And yeah, actually, what does it mean for us? That if we are really talking about sensitive data, so this is a logging function, that's the key you see. So the handle, this is not something that you want to give someone because you just use this long key just to get this reference. And if you have this reference inside your super private VI, it's accessible, and the attacker can do anything with the reference. So any VI in the PPL can be actually saved. Yep.
Did you try inlining the VI?
No.
that should that should
Should
do
it?
it. That should do it.
Should it? Okay. Okay, but so our idea was to check, what should we do in our API to be safe, to be on the safe side. So I would say that any license in the API, in this case, if we are able to see all controls and indicators, is something that you should really avoid. And alright, with inlining, it's a good idea, but also it depends on what inside your VI. So not every VI can be inlined, but this is something to check first. Yeah?
Let me be clear, I'm pretty sure that what you already tried should work. I'm checking that. So I'm going to look that up. So the inlining, though, gets rid of the panel connections entirely. So.
All right. It's great. So I'm really happy that this checkbox exists, as I said. But the only solution we found, actually, is the VI. Because if we don't have sub-VIs, if we don't want to have sub-VIs, then we should put everything to our big VI. So all our sensitive data will be inside, and there will be no controls and indicators. Still, it's good to follow some rules for this PI. So it would be better to have it in this private library, because it will prevent the ability to run it directly if you have a reference, so it will be out of scope. So disable debugging, try to remove block diagrams, try to switch off error handling, and maybe clear default controls values just in case. So when we decided to create the VI, so it was not the question how we implement the API, because we don't need the API. So in the official toolkit they use CD level, and also they use Xnode. They don't exist, but they use it. And we didn't want to use Xnode, so we decided to switch to a .NET library. So we wanted to create a big VI that uses a .NET library that access licensing functions. And so again, this is a trace of a VI that calls several sub-VIs, okay, but it doesn't really matter, that in turn call a .NET library. And as you can see here, if you have a reference leak, you will see all references. If you have an error in your .NET call, you will have all references. And the thing is that these references, they're not like random. So you can really guess the next reference if you already know a few of them. So you can make your VI to produce an error. In .NET code, for instance, you just remove your library, so it will find the library. And then you know the reference, and in the next call you can at least easier guess the number. And once you know the number, you can again connect it to what you want. So the solution to that is to mute all errors and ensure that there are no reference leaks in your code that use your .NET library. Also, when you use the .NET library, so you can have very, very smart and complex stuff that calls your .NET DLL that afterwards checks your licenses, but your DLL can be replaced, and no one will check, no one protects you from that, and no one will check whether it's genuine or not.
So what we do is just put a CRC or a hash of the .NET.
There are better tools. So you can check the signature. There's this weird function you can use, and it does the trick. You just need to know about that. So it's not something really special, but if you forget to do that, then you can have this issue. So okay, we created the VI because we didn't know about the lining, and we faced the next challenge actually. So what we had, a part of our software suite, is actually classical plugin architecture with the core PPL and a lot of plugins that are actually inheriting from classes from a core PPL. And we have an API that calls core PPL functions. And obviously we wanted to have separate license for separate plugins because we have such a fancy system. So why not having separate license for separate plugins? So the idea was that somehow we want to be able to understand what feature is this PPL. No one should be able to change this, because otherwise someone can assign an activated feature to an not activated PPL, and it shouldn't break the plugin architecture. So this core PPL shouldn't have any idea about plugins. And it sounds very simple, but in fact it appeared to be a little bit more difficult. So first we started with just a method of a library that will return us a number that represents a feature. Not a good idea actually. So then we switched to private methods, but in this case no one will be able to call this method, okay? Then it will be a public method, but it will return an encrypted number. Okay, but everyone will be able to see it. It's also not good. Actually, what we wanted to have is something like a PPL signature. And since we were trying to use a method for that, it was not a good idea because you don't have a binary at this stage, so you can't use any fingerprint. So yeah, we sorted the data and continued our investigations. So there is another feature, encryption feature, as I said. So you can say, okay, my specific application is able to read some encrypted data. But yeah, actually, PPL is just a file, in fact. But unfortunately, we faced that it won't work with PPLs because probably when LabVIEW API use open PPL function, it won't use open file function. That is basically somehow cached by this protection model. So it would mean that we would need to store encrypted data somewhere. And yeah, we were thinking about temporarily saved encrypted data in a hidden place, but actually it's not a good idea either because when you have something decrypted once, then it's really easy to find it and then to replace it. We also tried alternate data streams, so this is something that is attached somehow to a file, and it has a path, and it's usually used for some malware. We almost succeeded, but we were able to open a PPL, a decrypted PPL that was a part of an alternate data stream, but we were not able to load classes from such a library. And yeah, actually then I remember that I was just looking at PPL code and just opened it in an editor, and at some point I saw it like this. So this program can be run in close mode. And yeah, actually I decided, why am I not using these 39 bytes for our signature? Because they're always at the same place, and actually you can use it for anything. So you can put a lot of data inside, and you can just override these 39 bytes with anything you want. And this will allow you to get the feature number from a PPL, and also to check whether this PPL is genuine. All right. So that was our solution for PPLs. So for API, just a few hints. So forget about password protection because everyone knows that just nothing. So don't forget to remove block diagrams. The drawback is that no one will ever be able to build something with your PPL, with your API. Also, it will cause some problems with builds because you will need to have a specific build for specific version of LabVIEW, and also environment language because they use different type devs for different versions of LabVIEW. Few important points: you will be checking your license periodically, so you will need to have a reference. You will need to have a timer. So there are four possibilities. So they all three. First, they actually come from, I think, kernel 32. So they all have benefits, drawbacks. Basically, they all can be tempered, but yeah, what can't. So we went for a specific function of .NET library we used, and so we were not able to temper it in 5 minutes. So we were fine with that. Also, you might think about code obfuscation. So again, this is something that was mentioned in yesterday's presentation. So if you have a VI that just says license okay, you can replace it with something like this. So you can replace a name, you can have some strange names, or you can have some redundant data just to confuse users. Some notes are on object-oriented protection. So, of course, your PPL will show all architectures, so all inheritance, method names, and everything. So you can reverse engineer it. That's something that we can't prevent. Don't forget about scope, because sometimes it's overlooked. So use these three. Don't use community scope because it's just unsafe as we see, because you can actually put any PPL instead of your friend. So just use the name of the PPL. Actually, to use the name of LabVIEW, so you will need to make friends again after you build your PPL. But it's just not safe. And actually, it would be nice to prevent also uncontrolled inheritance and to have something like final class in Java, just to protect from overriding classes inside your PPL. Just a few general notes. So there are other methods how to, not how to hack it, but you want to consider thinking about protection. So these two we already discussed. There are a lot of LabVIEW execution methods, so you can use them if you like, just to see what is available and what should you protect. There's also this key in INI file of LabVIEW. It switched on a lot of new methods, so you can also check that if you like. And also there are tools for compile code, so basically you can also modify your compile code if you like. But this was a separate discussion, so but if you want, you can just check what is this. It's very important to automate this process, so every measures we discussed can be used in Jenkins. So you can obfuscate your code in scripts, and you can sign your PPLs in post build. You can use envelope by command line, and use it. So what we also learned, there was some work on it, so it's very important to keep your tools up to date. It's very important to review strategies, maybe to change it between releases, because it will confuse also someone if someone wants to hack it. Also be careful about your input data, so don't allow people to just run your APIs just to see what happens and to get some insights. So the results of our journey. So for management, mostly they got a very professional, good-looking solution with a lot of possibilities how to create packages of our software. Hopefully, I think already we've got new revenue streams because we can easily adapt to customer needs. Also, we have usage tracking, so we can see, we can analyze this data and use it. So for us, we learned a lot of new things. We also made some changes to our just structures because, as I mentioned, it was kind of difficult to reflect it in our portfolio structure. So at the moment, we don't know how to hack it, but there's always a feeling, at least for me, whether we turn off our stuff or not. So there is still something that we are not sure about, and this is why it's very important to continue investigations and to prevent maybe some really stupid mistakes when you use such a fancy commercial system and you just abuse the API or use it in the wrong way, and your protection just goes down. Thank you.